बिस्मिल्लाहिर्रहमानिर्रहीम। इस लेक्चर में हम पढ़ेंगे यूनिट 6 यानी चैप्टर नंबर 6 9th क्लास। तो इसमें 9th क्लास की जो केमिस्ट्री है उसको हम पढ़ेंगे और ये है चैप्टर नंबर 6। तो यहाँ पर अगर देखें तो हमने कुछ न्यूमेरिकल्स जो क्वेश्चंस थे वो हल कर चुके थे, लेकिन इस वीडियो में वो न्यूमेरिकल्स कंसेप्ट असेसमेंट एक्सरसाइज जो है उसको हमने हल करना है। तो हमारे पास यहाँ पर ये कंसेप्ट असेसमेंट एक्सरसाइज है। यहाँ पर ये है 6.1 और यहाँ पर ये है 6.2। तो इसको हमने हल करना है बारी बारी। तो सबसे पहले 6.1 को हल करते हैं। तो ये बता रहे कि राइट द एम्पिरिकल फार्मूला फॉर द कंपाउंड कंटेनिंग कार्बन टू हाइड्रोजन इन दी फॉलोइंग रेशो। अब यहाँ पर देखें ना, जो ए है इसमें है रेशो है कार्बन और हाइड्रोजन का है 1 और 4। तो अब इसमें अगर देखा जाए तो ये दैट इज वेरी सिंपल। सो वी कैन से ये बता रहे कि कार्बन और हाइड्रोजन, तो पहले है कार्बन उसके बाद हाइड्रोजन है। तो अगर हम यहाँ पे लगा दें, यहाँ पे रेशो है 1.4, तो पहले है कार्बन और उसके बाद है हाइड्रोजन, यानी कि 1 कार्बन और 4 हाइड्रोजन हमारे पास है। तो अब ये बता रहे कि राइट द एम्पिरिकल फार्मूला। अब एम्पिरिकल फार्मूला जो है वो हमने यानी जो सिंपल रेशो है उसका यहाँ पर लिखना है। अब यहाँ पर चूँकि 1 कार्बन है अगेंस्ट 4 हाइड्रोजन, तो हम इसको मज़ीद सिंप्लीफाई नहीं कर सकते। तो लिहाजा इसका जो एम्पिरिकल फार्मूला रहेगा वो सेम ही रहेगा, CHO4 ही रहेगा उसका, यानी कि जो मीथेन है उसका ये एम्पिरिकल फार्मूला भी है और मॉलिक्यूलर फार्मूला। तो उसके बाद दूसरा जो है क्वेश्चन नंबर बी, इसमें मेरे पास जो कार्बन और हाइड्रोजन रेशो है वो है 2:6, यानी यहाँ पर देखिए 2 इसमें कार्बन है और 6 हाइड्रोजन है। तो हम लिख सकते हैं कि C2 और H6, यानी यहाँ पर अब अगर देखा जाए तो यहाँ पर वी हैव 2 कार्बन अगेंस्ट 6 हाइड्रोजन। तो अगर हम 6 को 2 पे डिवाइड करें तो हमारे पास 6 डिवाइडेड बाई 2 दैट विल बी इक्वल टू 3, 2 और 3। तो हम हमारे पास ये कह सकते हैं कि 1 हमारे पास आ गया 1:3 आ गया हमारे पास। तो हमारे पास हम लिख सकते हैं कि CHO3 जो है हमारे पास ये इसका जो है एम्पिरिकल फार्मूला क्वेश्चन नंबर बी का आ गया। तो इसका जो एम्पिरिकल फार्मूला है C2H6 का वो क्या है, CHO3, दैट इज एम्पिरिकल फार्मूला। तो उसके बाद हमारे पास से क्वेश्चन नंबर सी है। तो सी में हमारे पास जो कार्बन रेशो है वो 2:2, यानी सी 2 कार्बन और 2 हाइड्रोजन एटम। तो चूँकि देयर आर 2 कार्बन अगेंस्ट 2 हाइड्रोजन, सो वी कैन सिंप्लीफाई दैट 2:2। अगर हम 2 को 2 पे डिवाइड करेंगे तो हमारे पास 1 आ जाएगा। तो हम सिंपल लिख सकते हैं कि द एम्पिरिकल फार्मूला ऑफ क्वेश्चन नंबर सी इज वी कैन से CH, सिंपली CH इसका एम्पिरिकल फार्मूला है। उसके बाद एक क्वेश्चन नंबर डी, तो हमारे पास यहाँ पर ये 6:6 है। तो इट मीन्स कि 6 कार्बन अगेंस्ट वी कैन से 6 हाइड्रोजन, C6H6, दैट इज द फार्मूला ऑफ बेंजीन। इफ यू सिंप्लीफाई the formula, this is a molecular formula, 6 carbon against 6 hydrogen, so we will get simply formula CH, because 6 and 6 will be cancelled, and we will get a simple empirical formula of benzene, which is CHO. So so we can say that question number C and D have the same empirical formula, which is CH. Similarly, we can solve the question number you can say concept assessment exercise 6.2। इसको हम यहाँ हल कर सकते हैं। तो ये बता रहे हैं कि इसमें क्वेश्चन नंबर 1 जो है कि एस्पिरिन इज यूज्ड एज ए मिल्ड पेन किलर, देयर आर 9 कार्बन एटम्स, 8 हाइड्रोजन्स and you can say 4 oxygen atoms, इन दिस कंपाउंड राइट इट्स एम्पेरिकल एंड मॉलिक्यूलर फार्मूला। तो यहाँ पर हमें बताया गया कि अपने एम्पेरिकल और मॉलिक्यूलर फार्मूला दोनों को आपने लिखने हैं। तो इसको हम हल करते हैं इस क्वेश्चन को। तो यहाँ पर हमारे पास है क्वेश्चन नंबर 1। तो इसमें है, तो इसमें हमारे पास स्प्रिन स्प्रिन हमारे पास, और दैट इज मिल्ड पेन किलर है। तो इसमें हमारे पास कहते हैं 9 कार्बन एटम्स है। तो हम लिख सकते हैं कि यहाँ पर वी हैव 9 कार्बन एटम्स एंड 8 हाइड्रोजन एटम्स, 9H 8 हाइड्रोजन एटम्स you can say, and 4 oxygen atoms, O4। यहाँ पर हमारे पास फार्मूला, अब ये कह रहे हैं कि इन दिस, ये कंपाउंड जो है इसका एम्पेरिकल फार्मूला और मॉलिक्यूलर फार्मूला दोनों को आपने लिखना है। तो वी कैन से दिस इज दी मॉलिक्यूलर फार्मूला, ये उसका मॉलिक्यूलर फार्मूला है। दिस इज द मॉलिक्यूलर फार्मूला C9H8O4। अब एम्पेरिकल फार्मूला जो हम लिखेंगे, तो एम्पेरिकल फार्मूला को लिखने के लिए हमने इस फिगर को सिंप्लीफाई करना है। तो कैसे करेंगे, यहाँ पर देखिए हमारे पास 9 वी कैन से 9 कार्बन एटम्स है, 8 हाइड्रोजन एटम्स एंड 4 ऑक्सीजन एटम्स। सो इन दिस कंपाउंड, सो अब अगर देखा जाए तो यहाँ पर तो हमारे पास कार्बन रेशो जो हमारे पास है 9:8:4। अब यहाँ पर मसला ये कि ये जो फिगर है 9, 8 एंड 4, 9 रेशो वी कैन से 8 एंड 4। तो अब इसमें अगर देखा जाए हम, इसमें से हमारे पास कोई ऐसा फिगर नहीं है जो लोवेस्ट फिगर है, ये जो भी हाईएस्ट हो, यानी जब हम इस पे डिवाइड करें 9, 8 और 4 को, 8 का तो हो सकता है 2 पे अगर हम डिवाइड करेंगे तो 4 आएगा, लेकिन 9 का हमारे पास फिगर जो है वो यानी कि हमारे पास ऐसा फिगर नहीं है जिस पे हम तीनों को डिवाइड करके डिवाइड हो सके। फॉर एग्जांपल 2 जो फिगर है, 2 पे हम 8 को डिवाइड कर सकते हैं, 4 को डिवाइड कर सकते हैं, लेकिन 9 को नहीं कर सकते। तो सिमिलरली 3 जो फिगर है, इस पे हम 9 को डिवाइड कर सकते हैं, 8 को नहीं कर सकते, और 4 को भी डिवाइड नहीं कर सकते। सिमिलरली फिगर जो 4 है, इस पे हम इसको डिवाइड 9 को डिवाइड नहीं कर सकते, 8 को डिवाइड कर सकते हैं, और 4 को डिवाइड कर सकते हैं। लेकिन हमारे पास ऐसा फिगर नहीं है जिस पे हम सारे जो है इसको डिवाइड कर सकें। तो सो देयरफॉर वी कैन से दैट द एम्पेरिकल फार्मूला इज आल्सो वी कैन से C9H8O4। सो मॉलिक्यूलर फार्मूला and empirical formula are the same, so we can write that molecular formula is equal to empirical formula. So these two are the same in this case. So we can say that in question number 1 the empirical and molecular formula both are the same. उसके बाद हमारे पास है क्वेश्चन नंबर 2। तो क्वेश्चन नंबर 2 हमारे पास है विनेगर इज 5% एसिटिक एसिड, इट कंटेन्स 2 कार्बन एटम्स, 4 हाइड्रोजन एटम्स एंड 2 ऑक्सीजन एटम्स, राइट इट्स एम्पेरिकल एंड मॉलिक्यूलर फार्मूला। तो यहाँ पर अगर देखा जाए तो हमारे पास विनेगर जो है उसमें 2 कार्बन है, 2 कार्बन है, 4 हाइड्रोजन है और 2 ऑक्सीजन है। तो हम लिख सकते हैं कि यहाँ पर क्वेश्चन नंबर 2 हमारे पास है, क्वेश्चन नंबर 2 हमारे पास से एस्प्रीन का बता रहे हैं कि एस्प्रीन जो है, एस्प्रीन कौन सा है कंपाउंड हमारे पास, कौन सा, विनेगर, से विनेगर। एस्प्रीन वाज द फर्स्ट वन वी हैव ऑलरेडी सॉल्व्ड, सो वी कैन से दैट इज विनेगर व्हिच इज 5% एसिटिक एसिड इसमें है। तो विनेगर इज बेसिकली एसिटिक एसिड 5%। So in this vinegar, we have number of carbons. We can say we have carbon, hydrogen, and oxygen. So we have 2 carbon atoms and 4 hydrogens and 2 oxygen atoms. So we can say this is the molecular formula of aspirin. And if you want to simplify this molecular formula into empirical formula, so see empirical formula. So we know that we have digits of 2, 4 ratio. You can say here is the ratio 2, ratio 4, ratio 2 between carbon, hydrogen, and oxygen atoms. So this ratio we can if we divide this ratio by 2 with the figure 2, so we can say we will get here 1 and we will get here 2 and we will get here 1. So we will get a ratio of 1 ratio 2 ratio 1. So we have simplified this ratio into this. So we can say that the empirical formula in this case will be we can say C1H2 or O1. So simply we can write CHO2O. So this is the empirical formula. That's this one. So the molecular formula is this one, and the empirical formula you can say which is this one. Now we can say that is question number 3. So caffeine is found in tea and coffee. Write the empirical formula of caffeine. तो यहाँ पर अगर हम देखें, अगर इसको जूम करें तो हमारे पास जो कैफीन है उसका फार्मूला यहाँ पर दिया गया है. So we have caffeine formula, that is question number 3, and we can say that caffeine, and that is its formula C8H10 10 हो गया N4O2. तो ये हमारे पास है कैफीन. अब इसको हमने ये बता रहे कि इसको आपने इसका राइट द एम्पेरिकल फार्मूला ऑफ दिस कंपाउंड. सो एम्पेरिकल फार्मूला ऑफ कैफीन को हमने लिखना है. तो इसको कैसे लिखेंगे यहाँ पर? तो हमारे पास यहाँ पर जो रेशो है वो है बिटवीन कार्बन, हाइड्रोजन, नाइट्रोजन एंड ऑक्सीजन 8:10⁻⁴:2. तो ये तो हमारे पास है. दिस वन इज वी कैन से दिस वन इज द वी कैन से मॉलिक्यूलर फार्मूला. This one is molecular formula, and so in molecular formula the ratio is this one 8:10:4:2 between carbon, hydrogen, nitrogen and oxygen atoms. So if we divide these figures by a digit, which will simplify this. So this digit is I think you can say minimum, the lowest digit is 2. If we divide this all by 2, so we can get if we divide 8 by 2, so we can get 4. So we can, if we write here in this case you can say 8. If we divide 8 by 2, so in this case we will get 2 and 4. We will get 4. If we divide 10, this is the 8 figure and this is the 10. So if we divide 10 by 2, so we can say 2, 5. We can get 5. And if we divide 4 by 2, so we can get 2. If we divide 2 by 2, we can get 1. So the simplest formula, now we have 4 ratio 5 ratio 2 ratio 1. So this is the ratio between these atoms. So we can say that In this case, if we write this here, 4 ratio 5 ratio 2 ratio 1. So we know that we have this is the carbon, number of carbon atoms, and this is the number of hydrogen atoms, and this is the number of nitrogen, and this is the number of oxygen atoms. So you can write here that C4H5N2O. So this is the, you can say, this is the empirical formula. This is empirical formula, and the molecular formula is this one. I can say C8H10N4O2. So this is the you can say, so molecular formula. Of caffeine. So in this way you can now find out the empirical and molecular formula. Now we will solve the concept assessment exercise number 6.3. So the first question is, you can say, potassium chlorate is used commonly for the laboratory preparation of oxygen gas. Calculate its formula mass. So we have potassium chlorate having formula KClO3. So we have the we have it. So to calculate its we can say its formula mass को हमने इसको calculate करना है. So we have question number 1. We can say that is potassium chlorate KClO3. So that is we can say the potassium chlorate. So we have to find out its formula mass. So how to determine its formula mass? So simply we can say that in this case we have potassium chlorate. So for determination of formula mass of potassium chlorate, we have first to know the atomic numbers. You can say atomic. You can say this is atomic weight of each element. So this should be known in each case. So you can say, so first we have potassium, the atoms potassium, chlorine, you can say oxygen. So the atomic weight of this should be known. So now we have to find out the atomic weight of this one. So you can say the potassium atomic weight, you can say that is 39 if in unit mu, and the chlorine will be equal to 35.5 mu, and oxygen is 16 mu. So now we have to add these atomic weights in order to determine the formula mass. So formula mass of we can say formula mass of potassium chlorate will be equal to we can say, if we write here sum of the atomic weights masses, you can say atomic weights of each element. So in this case we have potassium, chlorine, and oxygen. So now formula mass of potassium chlorate in this case will be equal to, so the first one you can say this is potassium 39 plus the second one is chlorine, we have 35 0.5. The third one is we can say oxygen. So oxygen is 16, but we have 3 oxygens, so we multiply 16 by 3. Now if we add these, we will get 39 plus 35.5 plus 16 into 3, that will be equal to 48. So if we add this all, we will get a number. So we have 120 2.5. So we can say, and that will be AMU, and we can write it as 122.5 gram per mole. Gram per mole. So you can say, here you can say that it should be gram per mole, because AMU we can say that is, we cannot weigh the atomic mass unit. So instead of AMU we will weigh gram, the mass in gram, and if you weigh the gram in mass, we can say 122.5. It means that we have taken 1 mole of potassium chlorate. We've taken 1 mole of potassium chlorate. So 1 mole of potassium chlorate will be equal to 122.5 gram. So in this way you can find out the formula mass of potassium chlorate. So the second question is question number 2. So when baking soda, sodium bicarbonate is heated, carbon dioxide is released, which is responsible for the rising of cookies and bread. Determine the formula masses of baking soda and carbon dioxide. So we have to heat up the sodium bicarbonate, which is a baking soda. So after heating the baking soda, in the product we will get carbon dioxide, you can say. So we have to determine the formula masses of both the carbon dioxide and baking soda. So we have baking soda, sodium bicarbonate, and the questions, according to the question, says that if we heat up the baking soda of you can say bicarbonate, if we heat up, so it says that carbon dioxide is released. So now we have to find out the formula masses of these two formula mass of baking soda and formula mass of CO2. So now we have the baking soda. First we can say that now we have to find out the formula mass, we can say first of baking soda, it's a bicarbonate, so NaH CO3. So first we should know about the atomic weights of sodium, hydrogen, carbon and oxygen. So we have elements, we can say sodium, hydrogen, and you can say sodium, hydrogen, you can say carbon and oxygen. So the atomic weight of sodium is 23, you can say AMU, and that of hydrogen is 1 AMU. I can say that of carbon is 12 AMU, that of oxygen is 16 AMU. So if you put these values in the formula, if you add this all, so we have the sodium of atomic weight is 23, and that of hydrogen is 1, that of carbon is 12, and that of oxygen is 16. We have 3 oxygen, so we will multiply the 16 with the 3. So we can say that 23 plus 1 plus 12 plus 48, and if we add these all, we will get that of we can say the formula mass we can say of so we have 84 AMU, or you can say that will be equal to 84 gram per mole. So if you take 84 gram, so you can say 84 gram of sodium bicarbonate will be equal to 1 mole. So similarly we can find out the formula mass of we can say of carbon dioxide. So this is carbon dioxide, so we have to find out the formula mass of this carbon dioxide. So first we should know the atomic weights of carbon and oxygen. We already have 12 and 16, so we should add atomic weights of carbon and oxygen, and from this we will get the the formula mass of carbon dioxide. Now CO2, we can say CO2, the formula mass we have to determine. Formula mass is unknown, so we know that the atomic mass of carbon is 12 and that of oxygen is 16. So if you put these values in the formula, so we have 12 of carbon plus 16 of oxygen. So since we have 2 oxygen, so we will multiply the 16 with the 2. So from this we will get 32, and that will be equal to 4 or 4 20 44 you can say mu, or we can say 44 gram per mole. So it shows that if we take 44 gram of CO2, that will be equal to, it means that that is equal to 1 mole of CO2. So in this way you can find out the formula masses of you can say of carbon dioxide and that of sodium bicarbonate. So this one we have to solve question number 3, and this is you can say following compounds are used as a fertilizer. Determine the formula masses. So the first one is you can say urea, and the second one is ammonium nitrate. So we have to determine the formula masses just like we have determined in the previous question number 2. So we have I can say urea, its formula is this one, NH2 whole twice U, and the second one is you can say ammonium nitrate, which has a formula of NH4NO3. So it's this one. So we have to find out its formula masses step by step. So first let's find out the formula mass of urea. So question number 3, we have urea, and urea has formula mass, you can say formula is whole twice CO. This is the formula of urea. So we have to find out this is the first one, you can say question number A, and question number B is that of ammonium nitrate, which is you can say NH4 NO3. This is the ammonium nitrate. Now first determine the formula mass of urea. You can say formula mass, that is unknown. So in order to find out the formula mass of you can say urea, NH2 whole twice CO. So we should first know the atomic weights of each element which include nitrogen, which says 14 mu. So similarly we have hydrogen, which is we can say atomic mass 1. So carbon has atomic mass of 12 mu, and that of oxygen has atomic mass of so we can say this is 16 mu. So in order to find out the formula mass of urea, we have to put these values in the formula. So we have a number of nitrogens. I think we have that is in this formula we have two nitrogens, and formula of atomic weight of one nitrogen is 14, so that will be equal to 28 mu. Similarly we have 4 hydrogen, because if we multiply this 2 with this 2, so we will get 4. So we have 4 hydrogen, that is equal to 2 2, and that is equal to 4. So similarly we have carbon, that is a 1. So carbon is 1, 12, 1, that is equal to 12. And we have oxygen. In case of urea we have oxygen, atomic mass of oxygen you can say that is 16. So we have one oxygen, so that is equal to 16. So if we add this, or we can say we will get 28 of that of nitrogen, and that of hydrogen is 4 atomic weight, while that of we can say carbon is 12, and that of oxygen is 16. So by adding these value we can get the formula mass of urea as 60 I can say gram per mole. So it means that if you take a 60 gram of urea, that is NH2 whole twice Cu, and that will be equal to 1 mole of urea. So this one can say urea. So 1 mole of 60 gram of urea is equal to 1 mole of urea. Similarly, we can find out the formula mass of that of ammonium nitrate. So in this case we have the atomic masses of each element. The second we can say second one is that of ammonium nitrate, NH4, we can say ammonium nitrate, and we have to find out its formula mass, which is unknown. Formula mass that of ammonium nitrate is unknown. Now in this case we have know that nitrogen has atomic mass of 14 mu, while that of hydrogen is you can say 1. So we have 4 hydrogen, so that will be multiplied by 4, and that will be equal to 4 AMU. Similarly we have nitrogen, which is atomic weight of 14 AMU. Also oxygen, that is 16, and we have 3 oxygen, so that will be equal to 48 mu. So if we put these atomic weights, you can say these all in this formula of formula of ammonium nitrate, so we will get, so we can say the nitrogen atomic mass is 14 plus that of hydrogen is 4 hydrogen, so we have plus 4 plus nitrogen has also 14, and that of oxygen we have 3 oxygen, so that will be equal to 48. So by adding these value we can get we can get 80. So 80 will be the atomic we can say formula mass of that of ammonium nitrate. So it means that if we take 80 gram of you can say ammonium nitrate, and that will be equal to 1 mole of ammonium nitrate. So this is in this way we can find out the formula mass of ammonium nitrate. Now we have to solve the concept assessment exercise 6.4. So you can say we have first questions which says that calculate the mass of 1 mole of copper, iodine, potassium and oxygen. So we have to determine the mass of 1 mole of each copper, iodine, potassium and oxygen. And the second one is differentiate between gram formula mass and gram molecular mass. So let's solve the first. Calculate the molar mass. Calculate the mass of 1 mole of each element. So this is the, you can say, this is at page number 104 of 9th class chemistry. So let's solve the first question. So we have to first the question number 1. We have so the mass of you can say the mass of 1 mole of first one is we can say that is copper. So copper CEO. So we have to determine the mass of copper. Now we know that 1 mole is equal to of copper, but first time we should know about the atomic weight of copper. So we know that atomic weight of copper is equal to 63.546. We can say that is AMU. So now we can easily determine the mass and that atomic weight of 63.54 AMU, that is equal to 1 mole of copper. So now we can easily determine the mass of copper. Now we are given 1 mole, so we can say that 1 mole of copper, and we will multiply this with the atomic weight which is equal to 63.454 mu or gram per mole. So we can write here that we can say that it will be equal to 63.54 gram per mole of copper, that is a copper. So here copper, mole of copper and mole of copper will be cancelled, and here we will get 63.54 gram of copper. So we have here 63.54 gram of copper, which is equal to 1 mole of copper. Now the second one is, we can say that is the iodine. We have to determine the mass of 1 mole of iodine. Now here we have to determine mass of 1 mole of iodine. So we know that atomic weight of iodine that is equal to 126.90447 gram per mole. So we are given 1 mole, so we can write here that 1 mole, that is equal to 1, we can say 1 mole, we can write here that 1 mole multiplied by 126.904 gram per mole of iodine. So here we can say a mole will be cancelled, and we will get 126.904 gram of iodine. So it shows that we can say that 126.904 gram of iodine, that is equal to 1 mole of iodine, that is equal to 1 mole of iodine. So in this way you can determine the mass of iodine. So the third one is potassium. So we have to determine the potassium, in atomic mass of potassium, and then oxygen. So we are given 1 mole. Now let's determine the mass of you can say potassium. So 1 mole of potassium. So we know that atomic weight of potassium is equal to 39 gram per mole. So now we are given 1 mole, so we can write that 1 mole of potassium multiplied by 39 gram of potassium per mole of per 1 mole of potassium. So 1 mole of potassium, so 1 mole of potassium will be cancelled here. So we can get 39 gram of potassium here. So this is the answer. So from this it shows that 39 gram of potassium is equal to 1 mole of potassium. If we take 39 gram of potassium, it means that we have taken 1 mole of potassium. Now we have to determine the mass of oxygen. Now we have to determine the mass of oxygen, and we are given 1 mole of oxygen. So first we know that atomic weight of oxygen, that is equal to 16 gram per mole. So we are given 1 mole of oxygen, so we can write here that 1 mole of oxygen, that will be multiplied by 16 gram per mole of oxygen, and a mole of oxygen will be cancelled, and here we will get 16 gram of oxygen. So this is the answer, but from this calculations it is clear that 16, if we take 16 gram of oxygen, it means that we have taken 1 mole of oxygen. So 16 gram of oxygen is equal to 1 mole of oxygen. So this is the answer. Now we have to find out the question number 2, differentiate between gram formula mass and gram molecular mass. So that is you can say differentiate between gram formula mass and gram molecular mass. So first we can say that the gram formula mass, we have to take it to gram formula mass, this one. So gram formula mass, we can say that the formula mass of a substance expressed in gram is called formula mass. So when this formula mass, you can say when formula mass is expressed in gram, you can say expressed in gram, so that is called gram formula mass. Gram formula mass. So for example, an ionic compound is represented by the formula unit that presents the simplest ratio between the ions of a compound. For example, we have sodium chloride, you can say in this case we have sodium chloride. This is example, we take this example. So formula mass of this sodium chloride is formula mass of this sodium chloride that is equal to we can say we have previously determined it, that is equal to 58.5 AMU. AMU atomic mass unit. So we can say that is the formula mass. And gram formula mass, we can say this is the gram formula mass of sodium chloride. Now the AMU unit, you can say if we want to take to measure 58.5, it is difficult to weigh this AMU, you can say. So instead of AMU, if we expressed this mass in gram, which will be 58.5 gram, so we can easily weigh this mass 58.5 gram and balance. So we can say that if we express this 58.5 atomic mass unit AMU in a gram like this one, so this is equal to, so this will be gram formula mass, and that is equal to 58.5 gram, and the same is also equal to 1 mole of sodium chloride. So as we have previously discussed. So similarly, if we take another example of we can say KCl, for example we have KCl, so we can say that the formula mass of KCl is we can say 39 of potassium and 35.5 that is of chlorine. So if we add the two, we will get 74.5 AMU. Now the same case is above. AMU atomic mass unit is a unit. If you want to take this for 74.5 by weighing this, so it is difficult for us to weigh AMU. So instead of AMU, if we expressed this 74.5 in gram, so we can easily take this 74.5 gram of KCl. So we have here expressed in gram, so we can say that that is the gram formula mass of KCl. यहाँ पर हमने जो इसका जो मास था, फार्मूला मास KCl का, वो 74.5 था, AMU था. अब AMU को बैलेंस पे अगर हम वेट लेना चाहें तो मुश्किल होता है AMU यूनिट को ना, तो लिहाजा हम AMU की जगह अगर इसको ग्राम में ले लें तो हमारे लिए आसानी होती है. तो अगर हम AMU को ग्राम में रिप्रेजेंट करें तो उसको हम कहते हैं ग्राम फार्मूला मास. Similarly, this was the gram formula mass. Similarly, this is the gram molecular mass. So how to represent the gram molecular mass? So अब यहाँ पर हमने ग्राम molecular mass को मालूम करना है. तो वो क्या होता है? तो अब ग्राम molecular mass क्या होता है? For example, हम ले लेते हैं water का. We have an example of water. So we know that molecular mass, we can say molecular mass of H2O, that is equal to 2 plus 16, that is equal to 18 AMU. 18 AMU, you can say. So अब you can say अब यहाँ पर ये जो 18 AMU है, इसको यानी इट्स डिफ़िकल्ट टू मेजर 18 mu। तो अगर हम इसी मास को ग्राम में रिप्रेजेंट कर लें तो ये हो जाएगा हमारे पास फिर ग्राम मॉलिक्यूलर मास हो जाएगा, ग्राम मॉलिक्यूलर मास ऑफ वाटर, एंड दैट विल बी इक्वल टू 18 ग्राम पर मोल। तो ये हम पहले भी पढ़ चुके हैं। तो अब यहाँ पर यानी कि अगर हम मॉलिक्यूलर मास को ग्राम में रिप्रेजेंट करें एमयू की जगह, तो उसको हम कहते हैं ग्राम मॉलिक्यूलर मास। तो सिमिलरली यहाँ पर अगर हम ग्लूकोज की मिसाल ले लें, ग्लूकोज वी हैव फार्मूला ऑफ C6H12O6। so we know that we can say the molecular mass of that of glucose is molecular mass of glucose C6H12O6 is equal to 180 gram per 180 AMU एटॉमिक मास यूनिट। तो अब यहाँ पर भी एटॉमिक मास यूनिट आ गया। तो अब एटॉमिक मास यूनिट को अगर हम इसका वेट लेना चाहें, मास लेना चाहें इस बैलेंस पे, तो हमारे लिए मुश्किल होगा। तो इसलिए अगर हम AMU की बजाय इसको रिप्रेजेंट करें ग्राम में, यानी अगर हम ग्राम मॉलिक्यूलर मास ऑफ ग्लूकोज यू कैन से C6H12O6, दैट विल बी इक्वल टू 180 ग्राम। तो इसको कहते हैं, और ये बराबर होगा 1 मोल के, to 1 mole. So if the molecular mass is represented in gram, so we can say this is called gram molecular mass. अभी हमने पढ़ना है कंसेप्ट असेसमेंट ऑफ एक्सरसाइज 6.5। तो यूनिट 6 यहाँ पर ये है, और यहाँ पर अगर हम देख ले तो ये पेज नंबर है यहाँ पर हमारे पास 106 है पेज नंबर। तो यहाँ पर हमने इन क्वेश्चंस को हल करना है। तो पेज ये है 106 पे of chemistry 9th class. So the first question is the molecular formula of compound used for bleaching hair is H22. Calculate first one is you can say mass of this compound, that would contain 2.5 mole. The second one is number of moles of this compound, that would exactly weigh 30 gram. तो यहाँ पर जो क्वेश्चन नंबर 1 है, इसमें हमें बताया गया है कि आपके पास H22 है। तो H22 जो है इट्स यूज्ड फॉर ब्लीचिंग हेयर। सो अब हमने इसका मास जो है मालूम करना है। एक पार्ट में हमने इसका मास मालूम करना है, और मोल हमें यहाँ पर इसके लिए गए हैं कि 2.5 मोल्स यहाँ पर मोल ऑफ कैन से मोल ऑफ H22 दैट इज इक्वल टू 2.5 मोल्स। अब मोल से हमने मास मालूम करना है, तो इट्स वेरी इजी। तो इसको हम मालूम करते हैं। हमारे पास मोल हमारे पास है 2.5 moles of H2O2. So we know that a formula mass you can say of H2O2, that is equal to 2 hydrogen 2 plus 32, that will be equal to 34 gram per mole that is the formula mass of H22 हाइड्रोजन पेरोक्साइड। सो यहाँ पर हम मल्टीप्लाई करते हैं, चूँकि यहाँ पर मोल्स है तो हमने मोल्स को कैंसिल करना है। सो वी हैव 34 ग्राम पर मोल ऑफ H22, यहाँ पर भी H22, तो ये मोल ऑफ H22 ये कैंसिल हो जाएगा। तो हमारे पास हम यूनिट हमारे पास यहाँ पर रह गया, ग्राम रह गया सिर्फ यूनिट हो, तो हम लिख सकते हैं कि दैट विल बी इक्वल टू 2.5। अब जो मोल तो कट गए, ये तो कट गए ना, उसके बाद हम लिख सकते हैं कि 34 ग्राम ऑफ H2O2। तो अब डिवीजन में तो कुछ भी नहीं, क्योंकि ये भी कैंसिल हो गया। तो 2.5, so you can say that 2.5 into 34 gram of H2O2, and that will be equal to 85 gram of H2O2. So you can say that it's 85 gram of H2O2, that is the mass of it is a mass. So which we have to determine, so this is 85 gram of H2O2. So you can say that 2.5 moles of H2O2 contain 85 gram of H2O2. अब सेकंड इसका जो पार्ट है, पार्ट बी, बता रहा है कि नंबर ऑफ मोल्स, कैलकुलेट द नंबर ऑफ मोल्स ऑफ दिस कंपाउंड विच वुड एग्जैक्टली वे 30 ग्राम। 30 ग्राम ऑफ H2O2 को हमने मोल्स में कन्वर्ट करना है। सो यहाँ पर हमने, हमारे पास है 30 ग्राम ऑफ H2O2, तो इसको हमने मोल ऑफ H2O2 में कन्वर्ट करना है। तो नाउ वी हैव the formula, you can say formula weight of H2O2, you can say that is equal to H2O2, and that is equal to 34 gram per mole, we already know. So we have 30 gram of H2O2, and the formula mass of H2O2 is 34 gram per mole of H2O2, and size also we can say H2O2. So a gram of H2O2 and gram of H2O2 will be cancelled. So we have units remaining 30 gram is cancelled already. So 30 mole of H2O2 divided by 34. So if we divide 30 by 34, we can get 0.882. So this will be equal to 0.882 mole of H2O2. So we can say that if you write here that 30 gram of H2O2 is equal to 0.882 mole of H2O2. So this gram of H2O2, that is equal to 0.882 mole of H2O2. So in this way you can convert the gram into mole. Now we have can say the question number second. So this one, so it shows that a spoon of table salt sodium chloride contains 12.5 gram of this salt. Calculate you can say the number of moles of it contains, तो यहाँ पर हमारे पास 12.5 ग्राम ऑफ टेबल साल्ट है, तो इसको दिया हुआ है, इसको हमने मोल में कन्वर्ट करना है। तो कैसे कन्वर्ट करेंगे? दिस इज आल्सो वेरी इजी। सो बिकॉज वी हैव previously calculated this you can say previously we have converted this now let's start it। तो यहाँ पर हमारे पास 12.5 gram of sodium chloride है, and we have to convert it into mole. So how this should be done? So now we know that the formula mass of you can say sodium chloride that is equal to 58.5 gram per mole. Now we are given 12.5 gram, so we can say that 12.5 gram of sodium chloride that will be multiplied by the formula weight of sodium chloride, which is 58.5. We can say that that will be written this such. We can say 58.5 gram of sodium chloride equal to 1 mole of sodium chloride. So here we can say that gram of sodium chloride and gram of sodium chloride will be cancelled, and we should get 12.5 mole, we can say mole of sodium chloride divided by 58.5. So if we divide 12.5 divided by 58.5, and that will be equal to 0.2136. So 0.2136 mole of sodium chloride. So in this way you can convert the gram of you can say gram of sodium chloride into moles of sodium chloride, and so this is gram, this is the mole. तो अभी हमने क्वेश्चन नंबर 3 को हल करना है। तो क्वेश्चन नंबर बता रहा है कि बिफोर द डाइजेस्टिव सिस्टम एक्सरेड पीपल आर रिक्वायर्ड टू swallow suspension of we can say barium sulfate, calculate the mass of 1 mole of barium sulfate. So अभी बता रहे हैं कि डाइजेस्टिव सिस्टम जो होता है इंसान का, उसका एक्सरे करने से पहले लोगों को चाहिए होता है कि वो बेरियम सल्फेट को काले, और उसकी गोलियाँ होती है उसको काले, तो उसके बाद फिर उसका एक्सरे किया जाता है। तो ये बता रहे हैं कि यानी कि मास ऑफ बेरियम सल्फेट को कैलकुलेट करना है, 1 मोल यानी मास ऑफ 1 मोल ऑफ बेरियम सल्फेट को आपने मालूम करना है। तो आइए इसको मालूम करते हैं। मास ऑफ 1 मोल ऑफ बेरियम सल्फेट, so you can say this is a mass of 1 mole of barium sulfate to determine it. Question number 3. So barium sulfate, so you can say formula. So अब कह रहे हैं कि calculate the mass of barium sulfate. We are given 1 mole of barium sulfate, so we have to calculate mass of barium sulfate from 1 mole of barium sulfate. So now first we have to find out the formula weight of barium sulfate. So we know that formula weight of barium sulfate and that is equal to 233.38 ग्राम पर मोल, 233.38 gram per mole. Now we know that we have to determine the mass from mole. So we can say that 1 mole of barium sulfate that is will be, if you multiply with the the formula weight of barium sulfate. So यहाँ पर we have 233.38 gram divided by mole. You can say 1 mole of barium sulfate. Here is also, you can say that is also barium sulfate. So mole of barium sulfate and mole of barium sulfate, this will be cancelled, and we have a unit remaining, which is gram. So you can say, तो अब यहाँ पर हम लिख सकते हैं कि 233.38 gram of barium sulfate, you can say. So this is already equal to, because these all units are cancelled, so we have remaining only 233.38 gram of barium sulfate. So you can say that 1 mole of barium sulfate, that is equal to 233.38 gram of barium sulfate. So this is the answer of this question. तो अभी हमने हल करना है यूनिट 6 असेसमेंट जो एक्सरसाइज है 6.5, तो इसको हल करना है, और ये है पेज नंबर कैन से दैट इज 108, पेज नंबर 108 पर मौजूद है। तो इसको हमें हल करना है, असेसमेंट एक्सरसाइज 6.5। अब ये बता रहा है क्वेश्चन नंबर 1, इसमें जो है वो कह रहे हैं कि एस्पिरिन इज कंपाउंड दैट कंटेन कार्बन, हाइड्रोजन एंड ऑक्सीजन, इट इज यूज्ड एज ए पेन किलर। An aspirin tablet contain 1.25 into 10 raised to the power 30 molecules. So how many moles of these compounds are present in these tablets? तो यहाँ पर हमें मॉलिक्यूल्स, नंबर ऑफ मॉलिक्यूल दिया गया है यहाँ पर, तो इससे हमने जो है मोल्स को मालूम करना है। तो यहाँ पर इसमें हमें जो है दिया गया है number of molecules. Aspirin tablet, you can say this is question number 1. So we have aspirin tablets, aspirin tablets. So you can say it contain hydrogen, oxygen and carbon. So aspirin tablets contain molecules. तो इसमें molecules कितने हैं? 1 point number of molecules in aspirin tablets, number of molecules in aspirin tablets, so that is equal to 1.25 into 10 raised to the power 30 molecules. So you can say 30 molecules. Now we have to determine number of moles. अब इसमें हमने मोल मालूम करना है, नंबर ऑफ मॉलिक्यूल्स में दिया गया है, तो नंबर ऑफ मोल्स को जो है हमने मालूम करना है, दिस अननोन। सो अब कैसे करेंगे इसको? तो यहाँ पर अगर देखा जाए तो हमें एवोगाड्रो नंबर जो है का कंसेप्ट आता है, एवोगाड्रो नंबर which is represented by Na, and that is equal to 6.02 into 10 raised to the power 23. So it may be particles, you can say, it may be molecules, and it may be atoms. So in our case we have molecules, so we can say, and this is equal to this Avogadro number is equal to 1 mole, that is equal to 1 mole. So now we have to determine the number of moles. So we can say that we have 1.25 into 10 raised to the power 30 molecules. If we multiply this, we know that we have to find out the number of moles. So we can say, if multiply with that, we know that 1 mole is equal to 1 mole. You can say 1 mole is equal to 6.02 into 10 raised to the power 23 molecules. Now we have here number of molecules cancelled. This one is cancelled. So the unit we get is a mole. So we have number of mole unit remaining on. So we can say, we can write here that 1.25 into 10 raised to the power 30 mole divided by 6.02 into 10 raised to the power 23. So if we divide, we can say that we can write in such a way also, that 1.25 divided by 6.02 into, so 10 raised to the power 30 into 10 raised to the power minus 23. So we can write that will be equal to, if we divide 1.25 with 6.02, we will get 7.525 into 10 raised to the power 30 minus 23, and that will be equal to 7.525 into 10 raised to the power 7. So because 30 minus 23, that is equal to 7. So, and this will be equal to a mole. So we can say this is a mole. So in this way you can determine the number of moles. So here will be also moles. So this is the answer for question number, you can say question number 1 for aspirin tablets. So we have to solve the second questions. It says that the method used to prevent rusting of sheaves and underground pipes in volume connecting the iron to a block of more active metals such as magnesium. This method is called cathodic protection. So how many moles of magnesium are present in 1 billion atoms of magnesium? अब यहाँ पर हमने जो हमें दिया गया है कि 1 बिलियन हमें एटम्स ऑफ मैग्नीशियम दिया गया है कि इसमें कितने मोल्स ऑफ मैग्नीशियम प्रेजेंट होंगे। तो हमने फिर एटम्स से मोल्स को बनाना है, यानी हमने एटम्स से मोल्स को कन्वर्ट करना है मोल्स में। तो आइए इसको शुरू करते हैं। तो नंबर ऑफ एटम्स of magnesium that is equal to 1 billion, and 1 billion is equal to 1 into 10 raised to the power 9 atoms. Now we have to convert the number of atoms into moles. So we have, you can write that number of atoms of magnesium is, you can say, 1 into 10 raised to the power 9 atoms. And now we know that 1 mole is equal to 6.02 into 10 raised to the power 23. In this case we have atoms, 1.0 atoms of magnesium. So we can write that 1 into 10 raised to the power 9 atoms multiplied by, we know that 1 mole of magnesium is equal to 6.02 into 10 raised to the power 23 atoms of, you can say. So atoms will be cancelled, and we will get 1 into 10 raised to the power 9, we can say, divided by 6.02 into 10 raised to the power 23 यहाँ पर mole of magnesium. So we can write here that will be equal to 1 divided by 6.02 into we can say 10 raised to the power 9 into 10 raised to the power minus 23. So you can say that will be equal to 0.166 into 10 23 minus 23 plus 9, that will be equal to minus 14 mole of magnesium. So this is the mole of magnesiums we have derived from that of 1 billion of atoms. So 1 billion atoms of magnesium, that is equal to 0.166 into 10 raised to the power minus 14 moles of magnesium. So this is the final answer.